The extraction of metals by electrolysis. Methods of extracting metals. Most metals are found combined with other elements as compounds in ores. These metals must be extracted from their ores before they can be made useful. There are two main methods of extracting metals from their ores. First is reduction with carbon, and the second is by electrolysis or using electricity. The reactivity series and metal extraction. The method of extraction which is most appropriate depends on the reactivity of the metal being extracted. The reactivity of a metal determines how it is extracted. For metals above carbon in the reactivity series must be extracted using electrolysis. For metals less reactive than carbon can be extracted from their ores by reduction. For copper, silver, gold, and platinum can occur in their pure form or natively and do not need to be extracted. Electrolysis is a process that uses electricity to separate the elements in a compound. Electrolysis is expensive, and so it is only used to extract reactive metals that cannot be extracted in other ways. Aluminium is a reactive metal that is found in the ore bauxite as aluminium oxide, Al2O3. Electrolysis breaks down the Al2O3 into aluminium and oxygen. As the aluminium loses oxygen, reduction takes place. What is the Wood equation for the extraction of aluminium? Aluminium oxide to be aluminium and oxygen. Electrolysis involves breaking down ionic compounds into simpler substances using electricity. An ionic substance contains charged particles called ions. An ion is an atom that has gained or lost electrons and so carries a positive or negative charge. Ions with a positive charge, such as metal ions, have lost electrons. Ions with a negative charge have gained electrons. Aluminium atom loses 3 electrons to be aluminium ions, or Al3+. In electrolysis, the ionic substance must be dissolved in water or melted so that the ions are free to move. In electrolysis, electrodes are used to pass a current through a substance. The substance that the current passes through and split up is called the electrolyte. The electrolyte contains positive and negative ions. What happens to these ions during electrolysis? Negative ions move to the positive electrode and lose electrons. This is oxidation. The positive ions move to the negative electrode and gain electrons. This is reduction. An easy way to remember what happens to the electrons during oxidation and reduction is to think oil rig. Oil for oxidation is loss of electrons. Reduction is gain of electrons. Equation written to show what happens to electrons during the oxidation and reduction are called half equation. For aluminium oxide to be aluminium plus oxygen, or 2Al2O3 liquid to be 4Al liquid plus 3O2 gas, the half equation of oxidation can be written as 2O2 minus to be O2 plus 4 electrons. For reduction half equation, we can write Al3 plus 3 electrons to be Al. Extracting aluminum use electrolysis from its ore. Why is it not possible to extract aluminum by heating its ore with carbon? Aluminum is more reactive than carbon, so its ore has a very high melting point, 2050 degrees Celsius. This means aluminum cannot be extracted by reduction with carbon. In electrolysis, the ore is dissolved in a compound called cryolite or Na3Al F6, which lowers the melting point to 1000 degrees Celsius. What processes occur at the electrodes during the electrolysis of aluminum oxide or Al2O3? At the negative electrode or a cathode, Al3 plus 3 electrons to be Al, that is reduction. At the positive electrode, 2O2 minus to be O2 plus 4E minus, that is oxidation. What is the overall equation for this extraction by electrolysis? Aluminum oxide to be aluminum plus oxygen, 2Al2O3 liquid to be 4Al liquid plus 3O2 gas. Electroplating. Here we have the anode, that the metal we want to cover the object is copper or Cu. So Cu will dissolve, changes into Cu2 plus, and the cathode is the object we want to electroplate it. The metal then will be covered by Cu2 plus that changes into Cu. So we get the metal object covered by Cu. Copper refining. The process of purifying impure metal is called refining of metal. The most important and most widely used method for refining impure metals is called electrolytic refining. Many metals like copper, zinc, tin, lead, nickel, silver, gold are refined electrolytically. For the refining of an impure metals by electrolysis, 1. A thick block of impure metal is made anode. It is connected to the positive terminal of the battery. 2. A thin strip of the pure metal is made cathode. It is connected to the negative terminal of the battery. 3. A water-soluble salt of the metal to be refined is taken as electrolyte. Here we have the cathode, that is the pure metal, and the anode is impure metal. The electrolyte is CuSO4. You can do the exercise from page 235 of your IGCSE book number 9.2 until 9.13.